Hello, my name is Laura Castano, and today I'm going to be discussing Lab 3, Physics 2211, Black Hole. The main objectives of this lab is first, finding the mass of the black hole. In order to do this, we need to use Newton's second law and build a relationship with gravity. The second main objective is analyzing the trajectory of the spaceship from a planet to a black hole. We need to estimate the initial velocity of the spaceship considering the two gravitational forces acting on it. Some key ideas and principles used in this lab is Newton's second law, which is used to calculate the net force on the star. Also, we need to use Newton's universal law of gravitation, which will be later on explained. Some relevant formulas is first the momentum principle. F net is equal to dp dt. The force acting on the system is gravity. So in order to find the mass of the black hole, we need to put the magnitude of the F net equal to the equation of gravity, because we can assume that the only force acting on the star is the force of gravity by the black hole. Then we solve for this equation, we solve for the mass of the black hole, and we get this equation. Also, we will be using the equation of F net, um, which its two components, its perpendicular component and its parallel component. Okay, so now moving on to part one of the computational model, we can see that the gravitational constant is this number. I added the mass of the star, which is given, and also the time interval. We're given that the time interval is 1 Earth day, and if we convert that to seconds, it would be 86,400 seconds. Now, the first step in the while loop is to define the velocity components. Then I calculated the initial and final momentum vectors, and then calculated the change in velocity and the change in momentum to finally calculate dp/dt, which is delta p over delta t. And because dp/dt is equal to F net, I added this here to include Newton's second law. Now, in order to calculate the trajectory of the spaceship from a planet to the black hole, we first need to add the black hole's mass, which we just calculated here. And also we need to define the ship's initial speed by trial and error, as we can see here. In order to calculate the net force on the planet, we need to consider that it is made by the net force of the black hole on the planet and the force by the ship on the planet. There were several calculations involved. We utilized the gravitational formulas to obtain the value of each force to ultimately obtain the net force on the planet. Afterwards, the next step is to calculate the net force on the spaceship. Once again, it is composed by the force of the black hole in the ship and the force by the planet on the spaceship. Then we had to apply Newton's second law. We used the velocity update as well as the position update formula, both for the planet and the spaceship. When we run the code, we can observe the trajectory of the spaceship, which is the pink line, and we can also see how it approaches the black hole. We can see now that the spaceship successfully approaches the black hole, orbits it, and manages to exit it without crashing. And these are the results. So what does it mean? How does the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components? Actually, there's no difference. They are equivalent as shown by the equations displayed. The rate of change of momentum can be calculated through observation of the object's position and velocity as a function of time. The net force is not something we can calculate unless we know the mass of the black hole, which is what we did in the code. So what if instead of wanting to take a quick look at the black hole and leave, you decide you want to enter into an orbit around the black hole? What initial velocity would your spaceship need to have in order to enter into some kind of orbit around the black hole? So we would need to calculate the gravitational forces from both the planet and the black hole and do all the necessary calculations similarly to what we did on the Glowscript code. Then we will know the effect the two forces have on the ship and that will allow us to calculate the initial velocity needed to the spaceship to not crash and exit the orbit. Thank you.